Hey, I don't know if anyone has told you guys, but global climates, they're changing. And honestly, it's going to be a problem. We just don't know how much of a problem. I'm interested in whether evolution can help limit the impact of climate change on wild populations. Now, I'm an experimental biologist, and studying evolution experimentally can be tricky. So let's say we wanted to look at the evolution of growth. First, we would measure growth within a population. We would then expose that population to a new climate for a period of time, and then remeasure growth. And if we see a difference in growth between the two measurements, we conclude that the population may have adapted to the climate it was exposed to. The problem with this approach is time. Evolution can take a while, and unless you're working with a relatively short-lived species, like bacteria, for example, it's often just too slow for us to detect experimentally. Now, are you listening? Because this is the clever bit. In order to work around this problem of time, we can use non-native species. For example, the fish on the screen is a pumpkin seed sunfish. If you've been fishing around here, you're probably familiar with them. Pumpkin seed are native here, but they were introduced into Europe in the late 1800s. Now, Europe has a milder climate than we do, and the pumpkin seed that have been living there have now been exposed to this climate for over 100 years. So we can use these non-native European pumpkin seed populations to test for adaptation to a warmer climate, under a much more realistic time frame than what we could achieve experimentally. All right, so how do we go about testing this? Well, in order to test to see if the European pumpkin seed have adapted to the warmer European climate, we collected pumpkin seed from 2 local Canadian populations, and we imported live pumpkin seed from 2 populations in Spain. And we're currently raising these fish in large outdoor ponds right here in Ontario. Now, under this design, I can compare Canadian and Spanish pumpkin seed, born and raised under identical conditions, which means any differences we see between them are likely the result of genetic evolutionary change. So far, we have found that Canadian and Spanish pumpkin seed have different metabolism, different temperature tolerance, and different growth rates. But we only see these differences when we measure the traits at warm temperatures. This tells me that the Spanish physiology is better suited to a warmer climate than the Canadian physiology. So I guess the Spanish pumpkin seed really is a senior pumpkin seed because it is adapted to the warmer Spanish climate. And if Spanish pumpkin seed can evolve within the 100 years since they were introduced, then Canadian pumpkin seed right here just might also be able to adapt to future changes in climate. Thank you.